Okay, so let's have a look at how to convert binary to decimal and decimal to binary. So let's take a look then. So binary, let's make this slightly bigger, shall we, so we can see it. Right, hopefully you can see that. What do you reckon? That should do. So binary consists of 2 digits, which is ones and zeros, and is typically used, well, it is used by computers, by processors to process information. Processors, CPUs, transistors, they only use binary to process information. So we've got ones and zeros. In decimal, we've got 10 digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 10 digits. And decimal is obviously used by human beings for various different things, but most notably to count. And as already previously mentioned, binary is used by computers to process information. Everything you do on a computer ultimately boils down to a 1 and a 0, which is processed by your CPU. Binary is also known as base 2, while decimal is known as base 10. So let's have a look how to convert one to the other. So it's been a while since I did this. I did this at college and probably at university. It's the sort of thing that they like to teach people that are learning about computers. I suppose it's quite fun. It's nice to know how to convert one to the other. It's not necessarily something that people typically know how to do, but I think it's quite fun. So let's see if I remember. So let's just make up a random number, shall we, in decimal. Let's go from decimal to binary first. Let's make up a number. Let's just say 54. There we go. So we got 54. So what you're going to want to do is start counting at 1 and double that number until the number you get to is greater than the number in decimal you want to convert to binary. So let's have a go. So let's start with 1, 1, 2, 4, 8, 16, 32, 64. Okay, we've gone far enough. The number we got to is 64, which is clearly greater than 54. So what we do is now, from left to right, we're going to try and add up these numbers so that they make 54. And it's worth noting that with these numbers here, you can actually make up any number between 1 and 64. So let's have a go then, shall we? So we obviously don't need 64 because that would give us too much. Now obviously we will need 32. So 32 plus 16 is 48. Okay, we'll take a 16. Now we've got an 8, so far we've got 48. If we add the 8 to it, we end up with 56. So we don't want 8. So as I said, we've got 48. If we add 4 to it, we get 52. So obviously we want the 4. And as you can probably guess, we want the 2 and we don't need the 1. So if we add 32 to 16, we've got 48. If we add the 4, we've got 52, and if we add the 2, we've got 54 in total. So this number here is 54 in binary. Let's have a look how many digits we've got. So we've got 1, 2, 3, 4, 5, 6, 7. Normally, when you see a binary number, it'll be 4 or 8 digits, for example. So let's just add an extra 0 there. And for consistency, we'll do 1, 2, 8. You don't actually need to do these two. To be honest with you, that number is absolutely fine. You can add as many zeros on the front as you like to the left. It won't make the slightest bit of difference. So let's have a look just to make sure that I actually got this right. So let's put it in there. Let's write 54. Let's get rid of that. Right, so let's have a look just to make sure I actually got that right, because it has been a little while. So let's see what it says online. So let's have a look. Firefox, best browser around. DuckDuckGo, best search engine around. So let's have a look then. So what was we doing? We was doing 54. So let's say 54. Here we go. 54 to binary. Let's have a look. Hopefully I'm right. So let's have a look what we got then. We got 0, 1, 1, 0. Let's look over here. 0, 1, 1, 0. And then we've got 1, 1, 0, 0. 1, 1, 0, 0. Well, I'm quite satisfied that that's right. So let's try going the other way. So let's just make up a random number, shall we? Let's go with, I don't know, let's go with 60. So we want to convert 60. So let's put 60 now. Now we want to convert, actually I've done that the wrong way. Let's have a look. Now I'm going to use the DuckDuckGo here. So I want to say 60 in binary, right? So that's the number in binary. So I'm going to copy that and I'm going to close that. So let's have a look at this number then. So that's the number we want to convert. So let's write it out so we can convert it. So we've got 0, 0, 1, 1, 1, 1. Well, that's fairly straightforward. So remember, this is 60. If memory serves. My memory is terrible, by the way. Let's have a go. 60. So this is what we want to convert. We want to convert 60. So let's have a go at that, shall we? Okay. Rightio. So 1, 2, 3, 4, 5, 6. Let's do what we did before. So we're going to do essentially the same thing. We're going to go 1, 2, 4, 8, 16, and we're going to go 32. And all we're going to do, just to make sure that this number is correct, let's get rid of that for a second then. So we're going to go 32 plus 16 is 48, plus 8 is 56, plus 4 is 60, and obviously we don't add these two because they've got 0. So you're just adding up the ones where there is a 1. So 32 plus 16 plus 8 plus 4 is 60. So we got to 60. So as you can see, it's fairly straightforward to go from binary to decimal and decimal to binary. It's quite fun to know how to do it. In fairness, it's probably not something any of you are going to do outside of a academic environment, but I think it's quite fun. It's just one of those things that you may find interesting. And that's it. So hopefully you found this video of use, and I'll see you next time.